Good morning, students. In this video I am going to explain definition of fluid and the few properties of the fluid. Before defining the definition of a fluid, I would like to discuss the classification of a matter. What classification of a matter? What is meant by a matter? Matter is nothing but anything which has the shape and anything which has the mass and occupies a volume is said to be a matter. Anything which has mass and occupies volume is known as matter. Okay, now let us consider this pen. We can see it has a mass, and we can also see it is occupying some space, so it is said to be a matter. Now if you consider the human beings, we are also a matter, as we have the mass and we are occupying some space in it. Now consider a water bottle. Water bottle is also a mass because it has water bottle is also a matter because it has mass and it is occupying volume. Now if you pour water in it, water is also a matter because it has mass and is also occupying a volume up to here. Now if you look at the bottle, here there is empty space. Here also we have air. Air is also matter because it has mass and it is also occupying a volume, so air is also a matter. So broadly, matter can be classified into different types. There are different types of matter. Generally, we define matter into two types: solids and fluids. Okay, at high temperature, matter exists at plasma state also, but we study about plasma state during PG. So at the moment, right now, we will discuss only two types of classification of matter, that is solids and fluids. Now once again, solids is divided into two types. First one, rigid bodies. Second, deformable bodies. Fluids, we know fluids classified into two types. One is liquid, another is gas or gases. The study of rigid bodies will be rigid bodies will be studied in engineering mechanics subject. About deformable bodies, we study in strength of materials. About liquids, we study in subject known as fluid mechanics, and about gases, we will study in thermodynamic subject. This is the basic classification of matter. Now if you come next one, rigid bodies. What is meant by rigid bodies? Before discussing rigid bodies, I would like to make a note. It is an ideal body. It means in real life there is no body which is as rigid body. Okay, in real life there is no body which is as ideal body. What is meant by rigid body? First I would like to explain what is meant by rigid body. Consider a body and you have applied a force. Mark 2 points, that is A and B. Before applying force, distance between the two particles, distance between them is x. Okay, you have taken a body and you have marked 2 points on it, and before applying the load, the distance between 2 points was x. Now you have applied a load on both sides. After applying load, if the distance remains same, distance remains same, and it won't change any shape, then that type of body is said to be rigid body. Okay, for example, consider a stone, and you have applied a force on both sides of a stone. It may not deform, or it may not change its shape as we are applying the force with our hands, but when the stone comes under the road roller, the stone will definitely fail and it will fracture. So in real life there is no body which is a rigid body. Up to a certain limit it may act as a rigid body, but after a definite amount of load applied, it will definitely fracture into, it will definitely causes deformation. That's why the rigid bodies which won't change its dimension or shape when subjected to forces or a movement or a twisting, then those type of bodies are said to be rigid bodies. What is another type of bodies? Deformable bodies. Body which changes its dimension and its shape when subjected to forces is said to be rigid bodies. For example, now see the explanation. Consider a body and mark points on it A, B, and let us say this distance between these 2 points is x. Now you applied a force on two sides. After applying the force, the distance between the two bodies will change. It means body got deformed, its dimensions are changed. Okay, that's why when the dimensions and the shape of the body changes when subjected to the force, those type of bodies are said to be deformable bodies. Now I will explain about fluid. What is meant by fluid? Generally we define fluid as substance which flows, which flows is known as fluid. It is the general definition, not a technical definition. In technical definition, we will define it in different way. Before that, I would like to explain the difference between the solid deformation and fluid deformation. Consider a solid. Consider a solid made up of any material. It is we have a body, and you have applied a shear force. Okay. At first, we have applied only a negligible amount of force. It's very negligible amount. It's like we can say 0.0001 Newton. Very negligible amount of force has been applied on this body. In that situation, the body may not deform. May it remain as it is, as before applying applied the force. Now, at the second step, we have increased its force. Then what happens? The body will try to deform. Body will deform a little. Now, what I have done? Once again, you have increased amount of force applied on it. You have increased the force. Then once again it will deform a little bit more. Okay. Now I will draw like a. Let us consider this edge only. Okay. Now before applying force, this edge was like this. Okay. At first, you have applied negligible amount of force. The body didn't get deformed. Now you have increased a little bit of force. Then it has deformed a little bit like this. Okay. And you have increased force once again, and the body gets deformed up to here. Okay. Like this, whenever you have applied force, it getting deformed. Okay. Now solid, there are few points. For a solid, whenever you have applied a force, it is getting deformed up to the certain limit only. It is not getting deformed continuously. Means if you have applied 1 Newton force, then it will deform a one step here. If you increase the load, then it will deform a little, and it will stop the deformation, right? So here we can see solid as finite deformation. Solid as finite deformation. Now if you take a fluid, let us consider it as a fluid element, and you have applied shear force here. What we have seen, as we apply the shear force, body gets deformed continuously. Body first second it will deform to here. Immediately with the second it will deform here. In third second it will deform next. It will deform continuously. It won't stop deforming as once we have applied the force. So that's the point. Means we can say fluid as infinite deformation. And fluid will start deform with negligible amount of force. Even if you apply 0.001 Newton force, fluid gets start deforming. it doesn't require a high amount of force. Even a small amount of force can applied on the fluid, it will start deforming. So we can conclude the difference between solid and fluid. Solid as finite deformation, fluid as continuous, we can say continuous deformation. Okay, and it requires significant force or enough, we can say requires significant force to deform. But here a small amount of force, or we can say negligible amount of force can deform the fluid. So we can write the definition of the fluid as a substance which deforms continuously under the action of shear force. I think you have understood the technical definition. Fluid is a substance which deforms continuously under the action of shear force. Now, if you may think this is the correct definition, but if you ask me, then I will say this is also not a exact definition of the fluid. We can say it is also a wrong. That is 99%. It is partially correct. Why? Because let us consider we have water in a glass. There is a water in it. Now a little amount of shear force is applied on this water, but water is not getting deformed. Then does we say fluid is water which is in this glass is not a fluid? Actually, the definition is a substance which has ability to deform under the action of shear force. Now, I think this definition shows the nature of the fluid. See, we have this fluid in this liquid in this glass tube, but now we are applying the force on the shear force. It is not deforming, but once the water is removed from the glass and we have applied a shear force on the fluid, it definitely gets deformed. That's why here the word ability is important. any substance which has the ability, which is capable of deforming whenever a negligible shear force is applied on it, is known as fluid. Okay. Right. Now we will discuss the properties of the fluid. That is, first property, nothing but a density or a mass density. Density or mass density or a mass density. Next, mathematically, density mathematically. First we will discuss mathematically. Mathematically, density is mass per unit volume. Density is denoted by rho, mass per unit volume. Mass units is kg and volume units is meter cube. Okay, it is an MK system. If you write in CGS system, it is gram per centimeter cube. Gram per centimeter cube. Now, how many grams? 1 gram per centimeter cube is equals to how many kg per meter cube? Okay, we will convert it here. In 1 gram, we have to write it here. 1 gram means 10 to the power of minus 3 in kg, minus 3 kg. Okay, centimeter and meter, it is 10 to the power of minus 2 to the power of 3 meter cube. Okay, if you write it here, 10 to the power of minus 3 kg by 10 to the power of minus 6 meter cube, that is equals to, if 10 to the power of minus 6 is moved to numerator, then it will be 10 to the power of 3 kg per meter cube. So we can write 1 gram per centimeter cube is equals to 10 to the power of 3 kg per meter cube. Yeah. Next, we have to remember a few values, density values of few material. Density of water is 1000 kg per meter cube, and at 4 degree centigrade, it is its maximum value. It is its maximum value of water. Okay, as temperature varies, density of water varies. That's why at 4 degrees centigrade we have got 1000 kg per meter cube. Next, density of air 1.205 kg per meter cube. 5 kg per meter cube. Next, density of mercury 13,580 kg per meter cube. approximately we can write 13,600. To make calculations easy, we use density of mercury as 13,600 kg per meter cube. Now, what is the physical meaning? What is the physical meaning? Physical meaning of density. Okay, what is the physical meaning of a density? Let us say we took 3 containers of 1 meter cube. 3 container of 1 meter cube. Okay. Now we want to fill these containers with different materials. Let us say in the first container I want to fill water, and the second container I want to fill air, the third container I want to fill mercury, okay, for in 1 meter cube. Let us see how much weight does it have. First consider. What is the density? Density is equals to mass by volume, and density of water is 1000 mass by 1 meter cube. So mass is equals to 1000 kg. 1000 kg. Now let us consider for air. For air, density is 1.205 kg per meter cube, and mass volume is 1 meter cube. We will get mass 1.205 kg. Okay. Now mercury density is 13,600. Its approximate value, it is mass and volume is 1. Mass is equals to 13,600 kg. Now, which container we can lift easily? We can say water container has a weight of 1000 kg, air as 1.205 kg, and mercury is 13,600 kg. If we want to lift these containers, then first we can lift this water container very easily. Okay, and if you want to lift the air container, we can lift very easily. If you want to lift the water container, it requires a little amount of force, little amount of energy, right? Then if you look at the mercury, it will be very difficult to lift with our hands. That is so because it has 13,600 kg. So what does it mean? Density of a material indicates heaviness of the fluid. Heaviness of fluid. Heaviness of fluid. How much does the fluid is heavy or fluid has weight? It indicated by the density. Okay. Next. Next we have another density known as weight density weight density. Mathematically, weight density is weight per unit volume denoted by omega, weight per unit volume. Its unit is Newton per meter cube. Newton per meter cube. What is Newton? We can write kg meter per second square into meter cube. This meter cancels. We can write kg meter square per second square. Right? Now we also know weight is equals to m into g. So substitute this mg here, we will get specific weight equals to m into g by volume. Now you can notice m by just now we have studied m by v. M by v is density. M by e is density. So specific weight is equals to density into gravity. Density into gravity. These are the two important properties of the fluid. Next, I would like to explain the definition of fluid. The definition of pressure. The definition of pressure. We all define pressure as force per unit area. Force per unit area. Okay, if you give this answer in the interview as force per unit area, they won't accept it. We won't accept it as answer for the definition of pressure. So we have to define the force. What kind of force? Is it a compressive force or tensile force or external force or internal force, right? So let's start. Let's define the definition of pressure. Let us say, let us consider a bucket in which water is poured. Water is there. Okay, and for this bucket it will have a cross section at the bottom surface. Okay, I am drawing separately here. It is bottom surface. Okay, and this is your bottom surface of the bucket. If you see, fluid is exerting pressure on the surface. It is a bucket. Let us consider it as a base. Now the fluid is exerting pressure on the fluid like this. Fluid is exerting pressure on the fluid. So the flow pressure or a force, fluid is exerting force on the surface. The force is acting external to this bottom surface, right? So that's why force is here external force. And if you see it, if you see, the force is acting perpendicular to the cross section. The force is acting perpendicular to the action. Whenever the force is acting perpendicular to the cross section, we say that force as normal force. We say that force as normal force. One more thing, one more thing. If you observe here, fluid is trying to compress the bottom surface. It is not trying to pull the bottom surface, it is trying to compress the bottom surface. That's why it is known as compressive force. So the pressure is defined as external normal and compressive force per unit area. I hope you have got the definition of the exact definition of the pressure. Okay, now if you write the units of pressure, it's a unit Newton per meter square, it is Pascal. It is Pascal. Okay, and if you write MKS unit, MKS newtons means in kg meter per second square, here meter square. So here you got matter meter, so we can write kg per meter second square. And if you write CGS unit, gram per centimeter second square. Now there are few other units in the pressure. That is 1 bar is equals to 10 to the power of 5 Newton per meter square or 10 to the power of 5 Pascal. Okay, 10 to the power of 5 Pascal. And now that's it, Newton per meter square, right? And 1 kilopascal, 1 megapascal is equals to 10 to the power of 1 megapascal is equals to 1 Newton per 10 to the power of meter square. Sorry. With this I conclude the definition of pressure and its units. Thank you.